You don't see any of the litter that I have on my screen. Okay, good. So the top link there, of course, is the link to get you to the GitHub for this, and you'll see there's actually three presentations in the material. Intro to Python, the Python object-orientedness, and then there's actually a course in there about how to use Python to talk to your electric vehicle. In fact, any kind of vehicle, car. There's actually an interface that allows you to tinker with Python against your car. So Python is open source, free. I know of two major places to get it. One, of course, is the python.com itself. And then there's a place called Anaconda that has a bundle that has a lot of the other things, like everything all put together, kind of convenient and a nice way to get it. And that's how I get it whenever I do it. It's got very strong support within its community. There are literally thousands, tens of thousands of packages available on the website called PyPy, P-Y-P-I, or the other way around, .com. And you can search by the name of the package you want. They call them modules, by the way, not packages. But you can search for the modules you want by topic, thing like that. So some of the examples of modules out there that people use a lot, numerical, like SciPy, NumPy, Pandas, and MPI for Pi if you're doing multiprocessor work across a large scale. Some scientists hook a bunch of computers together in a network and then spread the problem out amongst them and then collect the results and put them back out like that. We call that highly scalable type, programming. But all of these packages feature the ability to call things in Python that then drop down into other languages where they do them real fast. So NumPy and SciPy and all those packages, there are C++ native implementations so that they execute very quickly. And in fact, as you go forward, prefer to call one-off solutions to do things as opposed to doing for loops. So let's say you want to concatenate an entire list of strings. There's a way to do that with just a simple function call, or you could do it with for loop, right? Marching through the list. Well, you wouldn't want to do the for loop because once you make that one single call, you drop down into native language and machine language that then just does it very quickly. So it's a much more efficient way of doing it. You get much faster Python that way. There are, of course, user interface modules for user interface development. So you can do anything, make windows, dialogues, all those sorts of things. There are APIs to popular websites. And if you can't use the API to a popular website, you can actually scrape the web pages with something called Beautiful Soup that basically just digests the HTML behind the page and then lets you pick the pieces off. TensorFlow for machine learning, so you can get into that. It's got a very low bar to entry because all the hard work is done for you. There's some natural language processing with a package called NLTK, and facial recognition, which is Pi2FaceR, and there are other ones that you can use as well. So all of these Python objects can have things that are called properties and methods. So you'll know it's a method if you have to call it with parentheses, and if it's a property, then you don't have to use parentheses. So you want to know how long something is, there's a method to call for that, or a function typically. But if you wanted to know, well, we'll get to it. I'll show you, and you'll see more of that in the next lecture. So how do you get this? Well, I mentioned you can go to Anaconda and get it. You can get one called at InThought. There's a version that they curate, and then of course there's the main source, which is python.org. The way these other two organizations do it is they curate a version of Python installer and packages of a certain version. Sometimes they're a little bit later in the versioning cycle, so something might pop up on python.org or PyPy, and then you won't see it in Anaconda's releases until 6 months down the road. But you could go get it and you can mix them. So you can install Anaconda and then use pip, which is how you install modules from PyPy, and not have to go through Anaconda's method of doing it. We talked about PyPy, 130,000 packages. There's probably even more now because this was several years ago. If you want to do Python without commitment, none of us like commitment. You can go to pyfiddle.com and just play with the window that you can type your Python in and say go and try it out just to play with it. Probably is also hooked up to GitHub, so you can probably save your results, which is where we save results. In fact, that was the link I showed you up above. So there's a couple of miscellaneous things about Python we need to talk about. One is it's interpreted, which is why I mentioned that you should use methods rather than for loops because of the performance difference. It's case sensitive, so case will matter when you type variable names and such. It uses indentation rather than any kind of like squiggly braces or if ends or any of that kind of stuff if you come from BASIC. The comment character is a pound, so if you see a line with the pound, the stuff that occurs after that is comment, and the star is a wildcard, just like it is in Windows. And then there's the whole equals versus equals. You know that equals is an assignment operator, and equals is a Boolean operator, right? Comparison operator. So let's talk about the fundamental data types. Does anybody have any questions? We good so far? Okay. You can have numbers. There's no difference really between int and float. Not that much. I don't think it's even really differentiated at your level. There are strings. There are built-in data collections called lists, dictionaries, and tuples. Of course, lists are just an ordered list of things. Dictionaries are key value collections without any real order implied or that you should rely on. And then tuples are a very interesting thing. They're like a list, but they're immutable, and that becomes very important later on when you want to talk about how do you index into a dictionary, and there'll be a demonstration of that. So let's go and talk about numbers. You sign them with an equal sign. You can convert between integer and floating point. Oh, there are ints and floats. Sorry. You can convert between them with int and float. You put your number inside the parentheses. Numbers can be converted into strings with str. That's very lenient about what you convert from what. You cannot concatenate numbers and strings or numbers. Well, if you could, the concatenation character is plus. So if you concatenate numbers, you're actually adding. But let's just run through some examples. We're going to assign a variable called number, and then we're just going to print it so we see the result, and that's the result. Now let's talk about what I'm using to display all this. This is called a Jupyter notebook, which is organized as just a series of cells that have things in them. Some of the things are text, which is like you see right here, and some things are code, like you see here. And the things that are code, you can execute. And so I can go through and execute all of these cells that have, well, I can execute the numbers. I can execute this one as well. It executes, it's just text. But I can execute these cells as I go. And as I go, they all remain, the knowledge of what I got executed before stays with me. So I could load packages up here and then use them down farther in the Jupyter notebook. Scientists use this because it's like a really easy way to just play real quickly, mix things up, and then just save the entire notebook and bring it back, and it's all there. And they kind of like that. So let's convert number, which is an integer, to a float. Now it's a float. Turn it back to an int. We did that. Oh, now it's a string. Notice it's got quotes around it. In this series, we're going to take a number. We're going to go through examples of how to print something. So the first example is we're just going to build a string you can format a string. You can format a string and put it in a string. So in this case, the curly brace 0 says the first element in this list over here. So if I go curly brace 2 and do this, then that should now be number equals something with something after it. It'll look weird. So it'll be 20,018.3. That's what I'm expecting. And so everything's fine here. What I wanted to show down here is an example of, yeah, I can manipulate paths with concatenation, which is something we all tend to do when we start writing scripts. But don't do that. Use the OS path join method. The reason is it's smart enough to know which way the slash goes, depending whether on Windows or on Unix. And so it's a good practice to do that. Well, let's just execute this now and see what we get. I broke it. So that's what happens when you try to do things on the fly. Oh, I know why I broke it, because I went from 0 to 2. See, I'm giving you an example of how not to do something. There. So as I said, 2018.3. It doesn't matter. That's the first one. In the second one, if you put this little F here in front of the string, that says it's a format string. So just take anything between squiggly braces, go find the variable value, and then shove it in there. So you don't even have to have a dot format on the end. In this example, I'm just showing you can do the same thing and just put it right back into a string. So you can use this to concatenate and all kinds of crazy things with your strings, and then build them up and then finally print them out or use them. And here's some intervening characters. I'm mixing, of course, ints and string values to show you that all works like this. And as I said, use this method when building up path names because of the slash, which in Unix is one way and Windows is the other way. Now, why is that important? Well, it's important because notice how this says R, that says raw, which means that this slash is not, it's an escape character. You've probably seen /n if you've ever used any language, which is like new line. Well, if I don't put an R here, it's going to get terribly angry because now it thinks that /u is the escape character U, and it'll get all messed up. So the way you would have to fix that then would be to come in here and do something like this. And now I got to do all that editing. I didn't want to do all editing, so I just slapped the R in the front. So this should work. Yes, it works. Okay. So questions? Enlarge it a little bit. How about that? Oh yeah, no problem. Yeah, me too. So it's okay. So there are all kinds of operators that you can use. There's a plus, minus, subtraction, multiplication, division, modulus, exponents, and floor division. Remember that this is also concatenation for strings. There's comparison operators. Talk about equal equals, not equals, does not equals as well. Greater than, less than. Everybody familiar with those? And greater than or equal, less than or equal. Okay, strings. Strings are defined by either single or double quotes. If you start with a double quote, you got to end with a double quote. You've got to keep them consistent. It becomes really useful when you've got a format and then you want to declare something in the middle. So if I came up here and wanted to do this, if we wanted to put a string here, we'd want to use single quotes because we use double quotes on the outside. Because otherwise they'll close it. It'll close it. It'll end the double quote, right? If I use double quotes. But if I do this, then I can put an A here, and now this should come out as A1. Except that it broke. Why? Constantly telling. Oh, because it thinks it's supposed to be a variable. Oh. Okay, so we won't do that there. will go here. I'll have to think about that. Let me do it here. Well, there will be, well, here's an example. Yes. Notice right there. I have to use the other one because otherwise I'll terminate the starting one. So you have that. So you get two characters you can do that with. It'd be nice for three because sometimes it gets crazy. Did I keep this broken? No. Okay. So there's that. Characters could be accessed individually using index. So I could have gone example 0, and it would give me the H, etc. You backslash to escape. We'll talk about that. We talk about R, the raw, you put in front of the string so that it doesn't do any implied escaping in the string. And you can concatenate strings with the plus operators. We've really sort of talked about all this already. So that's your hello world. I've reassigned the string, so that's fine. Here I am going to print the first, second, third through the fourth character of the string, right? Right here, I'm showing that I can either use the double slash so that the first slash escapes the second one, or I can just slap an R on the front. It's the same thing, which is useful. There are string methods. So what are some of the string methods? Well, there's a Boolean check for, does it start with this prefix? Does it end with a suffix? Is it all alphanumeric characters? Can I replace a substring with a different substring? Can I split a string with a series of characters? That doesn't have to be just a single character. It could be more than one character. So if I've got a long string with foo embedded throughout, FOO, here, here, and here, I can split that string on those three characters. They disappear and they turn in, and it turns into a list. So the split will return a list. And by the way, there are examples right over here to show you what I mean by all of that. So does it start, if this is the string, does it start with that? Yes, it does. Does it end with SHP? Yes, it does. Are they all from America? No, etc. So here's where we split. We split with a slash. Now we get a list of the different components of the path, and the strip, of course, which says strip off dot ship. So it strips off that. If I strip with no arguments, it takes white space. So there's sometimes default behavior if no arguments is fine. It's kind of nice, as long as you know what's up. So we've gone through ints, floats, strings. Now we can talk about collections. The first one is list. It's an ordered list. It's delineated with square brackets, as you can see in the first cell. They're ordered 0 through 3. Indexing is by zero-based indexing. Lists can have different types. You do not have to have a list of just integers. You can have a list that contains integers and strings. Yes.
I noticed how you identify the string that it's going to the variable and not text that threw me off. So you had kind of a string of things around it. So then it's reading it. Like if you were concatenating like a string that you're setting plus.
You mean like sort of there?
Yeah. So how does it identify?
Okay. In this case, none of these are variables, which is interesting. But it's alerted that it needs to handle the string that follows differently because of the app. That's how it figures out that this.
So there could be a variable.
It's telling me there's embedded variables here. These aren't particularly variables, but they could be. More like, well, more like this one, that's a variable. Year is a variable. So it sees the F and it says, okay, look for all of the enclosed pieces that have curly braces. So wherever there's a curly brace, now I got to worry about variables. So that means, yes, that does mean that if I do this, if I want to put this in my string for real, I'm going to guess I have to do that. Now, I haven't actually practiced this because that's not really part of indicating that there's something embedded. It's a string, it's a character.
Yeah, I was trying to see how you identify it.
And of course, yeah, it can't handle that. And I've had that problem in the past. There's some sensitivity with the way the parser works that curly braces and things can be an issue. And quite honestly, I've solved it like this. I know, this is bad. Not true. And it's crazy that I should have to do that, but yeah. But the way it's picking it up is it says, oh, this is a hole that someone's going to stick a value in this case, from the variable curly, in this case down here, from a constant, a number 4. Any other question? So let's see. I was saying that you could put anything you could put in a variable, you could put in a string. It doesn't matter if it's an integer, float, whatever. And it could be a complex type, which we'll talk about next time. You retrieve them using an index, and the order is from 0. Start 0, 1, 2, 3. And there's a thing called list comprehension that lets you make lists and then manipulate them in very easy, quick ways and fast, because when you do it, you dive down into the native code that's part of the Python implementation. So it's quick. So let's see, we're going to make an empty list, which is the first line. And we're going to put some city names in our list. We're going to print it, and then we're going to print the first, second, and the third one, which are the 0, the 1, and the 2 indexed. When we do that, we see that we get, is that what you would have expected to get? Okay, good. So now let's make a bigger list. And let's talk about list comprehensions, because that's the really complex thing. It's not scary at all. But what it means is you get a list and you create, notice that these braces here, they're saying, I'm making a list. And I want to make a list of X values where X, and here's a tiny little embedded for loop, a for loop that says, for every X in this list up here, if it is divisible by 2, because that's modulus 2 is 0 when it's even. So if it's 0, then that means it's even. I want it in a list. So we're making a sublist of all the other items in the list that are even, like this. And so when I run it, I get only the even numbers. If you assume 0 is even. That makes sense? I can never remember, is it odd? 0 is not even, not odd, or is it not positive or negative? There's in math, there's one we think about.
Positive, negative, or true is negative, 0 or false.
No, but I mean in math, there's a thing that's they say 0 isn't either positive or negative or whatever. You need farther? Oh, you're getting up? Sure, no problem. No problem at all. Anyway, let's talk about the operations you have on a list. So if we have a list A, B, C, D, we can append an item to the list. And so when we append E, we get a new list that looks like that. You can sort a list. So you can say, hey, sort the list, and it just resorts it. I believe there's an argument you can apply to this that allows you to sort it using some sort of lambda expression. Yes.
Lambda, I believe it's
Yeah, like you make a little functoid and you pass it to it. It says, how do I compare my things? So why would that be important? Well, what if the items in your list were lists or tuples or dictionaries? So how do you compare the items in your list? Because lists can also be integers, floats, strings, etc. And so you might have to roll your own comparison function. But if you're just going to compare them, I mean, we're talking the difference between, using the language and using, full power. And, you won't get there right away, but it's available if you need it. You could reverse the order of the list. You can remove an item based on its name. So you say, go find the item of this value and remove it. You can insert an item anywhere in the list you want. So by saying 0, that means beginning. If you said insert 1, it would be after the first element, etc. So you have that kind of control. And of course, you get the count of the list. How many C's are there in this? How many values of that value in the list? So your list can have duplicates and then it would find them for you. All of these probably have functions that let you do things to find the items that when they get complicated data values, like I said, tuples, there's probably some way to do that. Dictionaries are another collection that's built into Python. And they're key value pairs. So it's basically, there's no order. Again, the dictionary entries can be of any type. And I think I actually do that here because I wanted to demonstrate that. You retrieve a specific item by getting the key value of it. And there's a thing called dictionary comprehensions that you make sub-dictionaries really quickly from dictionaries that you already have. So let's walk through the steps here. So we're going to make an empty dictionary, which is what this does. We're going to add a dictionary element at cat, that's the key, and it's going to be the value 1. Dog is going to have an entry of happy. And then the number 4, which is a key, is going to have the value bird. Now, is this crazy or what? Well, if your background is C, you're going, no, this is impossible. But yeah, there you go. And then here, we're going to index this dictionary element using a tuple. In other words, a collection of items. And under the hood, what it's probably doing is it's probably running through calculating a hash value for the item and just sticking it there, right? That's what's happening. But those are the values. Now we're going to print them. We're going to print cat, dog, 4, and 42. And everything should be sweetness and light if we don't edit the file while we're at it. And there we go. So we actually found all the values. Oh, notice I forgot that though. If I put it in, it'll be there next time. There. So that makes sense. It's weird, but it makes sense. What's your background language?
Bunch, but I mean, currently is from. It kind of feels like the association. It's kind of.
Yeah. Yeah. Okay, I'm not familiar with PHP. What's yours?
Basic.
Okay. So you're used to somewhat of a dynamic language, environment. And are you insufficient knowledge?
Yeah, this is all pretty much new to me.
Okay.
I work with systems that use Python.
Okay.
More of a user than cat.
Okay. If it gets to be water hole, if it gets to be drinking from a fire hose, let me know, and we'll kind of back off a little bit. This is for you guys, not me.
I'm translating it into what I do, which is really basic for itself.
Okay. Excel is a different kind of beast. Are you talking the Visual Basic for applications, or are you talking you're doing the cell map?
Settlement.
Okay, Got it.
Check out.
That's okay. You get that skill and you can't wipe it off. Everybody wants it. They hate it, but they want it. Make me a spreadsheet, but oh, you know. Okay, so what are we doing here? We're making we're making like a list of our cities, but we're doing, oh, now we have cities. We had names before, but now we can put the populations on as the value of the key value pair. And we're just going to print them and then we're going to print Austin. So we do that. That's pretty easy. Ta-da, right? Things to notice, everything came out in the same order. Yay, that's fine. I think there's an example down below where the order changes because they're not, like I said, you're not guaranteed on the order. So now let's talk about dictionary comprehensions. Now, you made a list by declaring square brackets, right? Put stuff in the middle. You make a dictionary, you know how to say, hey, here's a dictionary that's empty. So you know it's going to be curly braces. So the first thing you notice is that the whole thing is encased in curly braces, right? So that tells you I'm making a dictionary. And you know that you're making a dictionary and it's going to have these key value pairs. By the way, K and V, they're just random, they're just variable names. So what's important is thing on the left, thing on the right of the colon. And then I say for key value pair in this collection, go through the items and let's find the ones whose values are divisible by 2. I like even numbers. So that means we should get Houston and Dallas, right? Because Austin's got a 1 on the end. That's odd. So if we run this, we get Houston and Dallas. So it's doing exactly what we expected it to do. Does that make sense? Because comprehensions, you'll forget them, but then you'll remember that we were talking about it. And so if you do the comprehensions enough, that wound in your brain will become a scar and you'll remember it. So what did that items thing do? Well, if you look at items, it gives you a dictionary. It gives you a list of the dictionary items. But remember, I remade the city population, which, by the way, I could put back because, as I said, you can run the cells sequentially, but you can also run them non-sequentially. So I'll go up to this cell, run this, which now makes city populations have 3 values in it, right? And then I'll skip this cell right here that's going to reform it for me. And I'll just go down here where it prints the items. And now I should have 3. So the order in which you execute the cells, you can change them based on, oh, I really need to go back and redo that thing so that I can then change the cell bolt under it and do stuff, which is why scientists like it. It's very flexible, if that all made sense. And then, of course, one thing I wanted to show you is I could print this and it comes out like that. But there's also a package called print, which is pretty print, which allows me to pretty print things. In the case of a dictionary, it comes out the same, but later on you'll be manipulating things like JSON and all kinds of these objects. And when you do that, pretty print can print things so that you can read them a lot easier a lot better than just using the print function. So it'll become useful for that. So what can you do with dictionaries? What are the methods that are the principal methods you can use? Well, we talked about items, which that's, by the way, what this cell looks like. And when I execute it, it makes it nice text. So you can put HTML in the cell. So that's what's going on here. So you can print the items in the dictionary. You could get a list of the keys. You get a list of the values. You could pop a value off of the dictionary based on the key, which deletes it and gives it to you. So now you have Qs, right? Kind of. And you can clear all the items in the dictionary, which you can do with an assignment statement too. But it's there. Now there's one more base collection type embedded in Python or implemented by Python, which is called tuples. Tuples are a lot like lists. They're an order set. You don't use square braces. You use parentheses. They're very similar to lists. Okay, and they're immutable. And the reason they're immutable, this is why they exist, I think. You cannot take a mutable key and use it in a dictionary as a key. If you did, it would violate things, right? That you could grab the key and change it, and then the whole red black tree would get all messed up if you changed the key. So the rule is anything that you put as an index or in a dictionary has to be immutable. So you have to use tuples to do it. And there are methods that you can use to convert a list to a tuple. That's not really that much of a problem. So how do you make a tuple? Well, make it much like a list. You just use parentheses rather than square brackets. And if I print person here, I think it just says me, okay, my name. Okay, so here I am going to make a dictionary. I am going to index it by first and last name of several people as tuples, and then print them out. So that was pretty easy. That makes sense. And then they're going to do this one, but that one fails. Can anybody tell me why that fails? Okay, so the thing at 0 is what?
That is single equals instead of equally.
No, it's I stored a value at person sub 0, and it was a tuple, right? But tuples are immutable. So person sub 0 pulls the tuple out, and then I tried to assign it. You can't. Tuples aren't assignable because they're immutable. So you just remember that you can't change a tuple, which could be a good thing. You can pass it as a argument in an argument list, and you know that the person who got it is not going to manipulate it because they can't change it. That's another good idea. So how are we doing? We're doing really bad for time. Well, actually, we're not doing too bad. So we're going to go through the loops that you have. It's much like all the other languages you may be familiar with. You get ifs, you get if else's, and you get else's. So this, of course, is going to check the value of pi and tell me something about it, which you'll all be able to say. Let's see, pi, that's obviously wrong, but if pi is greater than 4, then it would come out here. If it's greater than 3, it comes out there. And if it's anything else, it goes here. So it should be not greater than 3 because I used the wrong pi. But what's interesting is, nope, I'm sorry, that's not that. So that's that. And notice that this is much like a switch statement or whatever. It's like 3 different cases, right? I could also implemented it like this using the indentation, where I've just indented and said else this or that or that. I don't think there's any performance change. Does anybody have any questions about the if? Okay, good. 4 is much like all your other for loops. What's really weird is Python gives you this else clause. Yes.
Sorry, I just jumped in
No problem.
to go repark. I've done a little bit of Python, and I'm still trying to like differentiate between different how. If you give an example.
Okay,
Like,
so
I think probably real super.
so as a language template, you have a construct that's if this condition, do that, else do this. So it's you can have cereal or you can have toast. Can't have both. And depending on what your condition is, I like cereal. Yes, true. I'm having cereal. So up here, the differentiator is that there's a value of pi that matters to me. In this case, if it's that, it's going to go down here and do this. Does that make sense? And if it's not, it'll come down here and in this case, let's make it simple for you. That it'll do that. Okay, does that make sense? In other words, if and else are hand in hand, you have to use both.
I've seen some other complicated, else and if statements where there's elif, all that and how that ties in. That's like something.
Okay, so I had that here. See, I have an elif. So it's if it's this, do that. If it's this, do this, and if else, do that. But that's really the same as this construct here, which you can think of as a separate, right? It's if do this, else do all of that. But then this is if this, then do this, else do this. Yes.
I don't have a switch statement, and is it different?
No.
So that's the equivalent of the switch.
Yeah. Yeah. So okay. You could do a weird thing. You could make a dictionary of key value pairs where the key is the thing, like let's say you calculate the value, whatever it's like, you're looking at ASCII characters. Okay, so you could have the key be the ASCII characters, and then the value could actually be maybe a lambda expression or a function point, a function, because you can assign functions to variables as well. So you could just like go, oh, if it's an A, call this function. If it's B, call that function. If it's C, call this function. And then you don't have to do any of the if thing. You just go index into the structure and go call this. So you get function pointers in a sense.
Which would be proficient.
I don't know. Because you get a context switch.
It really. A lot of ifs. There.
Oh, a lot of, yeah, remember, if you're doing if, else if, the average number of if checks will be half the number of items in the number of else ifs, right? Because on average, you'll run through at least that many Boolean checks. So, if you were up in the 256, it might be cheaper to just, put them in a dictionary and go jump off to it. Because half of 256 is 128. So we good? How are we doing? We're good. So the for statement, you have for loops like in other language, but they have this thing called else. And I always get this wrong, but loops are used to iterate over collections. Other languages have them. The word break and continue do the same sort of thing. For instance, here's a list. We're going to walk through the items in the list. We don't have a for I equals 0 through 7. The way you do that is you use a range function. This range function will return an iterator, basically, that the for loop will use. In the old days, they'd actually make a list of all the indices, and then you could just work off them. But now it's actually an iterator. So the for loop calls the iterator each time, generating the next index. And it doesn't do the 10. So it goes from 0 in this case to 9 number of indices. That last one is not part of the collection.
It's
open on one end, closed on the other, something like that. Yeah.
Of elements to process.
Pardon?
So it's gonna process 10 elements,
Yes.
starting with your initial number.
0. Yes.
So would then, if you said range 310, would it end at 12?
No. It would start at 3
and end at
And stop
9.
at 9.
Yeah.
Okay,
Yeah, it's not meant to mean
okay. so
do
it's
this
not a
many
count.
elements.
Okay,
It's do this up to this.
okay.
Now, if I'm not mistaken, oh,
Question.
yes,
So when they make AMRs, we have to manually go step by step. Or is it?
I've seen, there's actually a number of. An add-on to, Jupyter that allows you to use AI to generate initial code. You can go back and you can stick, you can tell the AI, stick what you're generating, stick it in this cell. Or you can do, or you can also do stick each line of the code in an individual cell. That's a little less useful.
yeah. Well, you can always put things in the cell after you've like worked on each little bit. You say, oh, I like this, and put it over here, and put it. I actually don't use Jupyter. I program Python all the time, but I don't use Jupyter because for me, it's just, I just put.
I've watched some of the programs use Jupyter to prove out method of an analytical method. Piece by piece, the whole point of an individual cell of Jupyter is you can make a series of cells to take an idea one step at a time. You can tell it, execute that step, execute the next
Right.
cell, see what the result is. You can stop and actually look at the result of the cell. That's what the in and out, as you see
Right.
in the practice.
Yeah, because whenever I think of LLMs, I always think like they're men with the something.
Well, are you talking data or are you talking code?
Well, if it's something else.
They are so. Go back to the idea of the range. The range, what I understand the range to do is it's actually a function that goes around in a loop. Basically goes around the loop. That's what he's referring to when he said, talked about an iterator.
Right.
The concept of an iterator is you ask it for a value, and it keeps going. It's how it, inside of the iterator, you can tell it what's stopping.
Okay.
That's how a range
Yeah.
works. Basically. That's how I understand it.
Yeah. So to answer your original question, you could do Python in a chat GPT environment, might be visual code. So
I'm trying to
and
figure out how they made.
well, TensorFlow is more like a library. So yeah. So well, we're running out of time, so let's just finish this. Then there's an AMA after the next hour. Come on in and we will chat away. And I'm perfectly happy to do that. So the interesting thing I want to point out is that the for loop has this thing called an else. You don't have to use it, by the way. You don't have to have an else on an if. But if you use it on a for loop, it guarantees that whatever's after it gets executed, whether or not there's any item in it. That's all it does. So there's that. There's a while loop, which is kind of like the for loop, right? Well, while something's true, do these things, blah, blah, blah. You can also have an else on that. And there's a thing I wanted to introduce. So here, for instance, we're just going through a loop. We're going to count and print the values from 0 to Yes, 8. That makes sense. And here's a while else. And as I said, this is actually should always be called. So while it's less than 9, and count is less than 9, but what if count is 10? The else is somewhat confusing for me. Here, always gets executed. So you make a while loop, but you can always guarantee that it gets that the else gets executed, whether it was one or none, no elements. It's kind of like a try finally. Anybody ever finally? Yeah, it's kind of like that. And so we're just going to that. I'll introduce this thing. When you're putting together an algorithm with a bunch of loops and stuff, and you haven't got time to put the innards in yet, but you want the loop to be, you don't want to listen to the compiler complain. You can use the word pass, which is no op. Because if I take that out, this will fail and complain because it's not valid Python, but now it is valid Python because it's a no op thing. That's all that does. Now, at the beginning of the talk, I talked about the modules you could go out to get at PyPy. There are some core modules that you'll use a lot. OS, which gives you interfacing capabilities to the operating system. Some more system-specific stuff in sys. Unix-style path name patterns, matter matching, stars, things like that, and glob. And if you do CSV read, file reading and writing, you might use CSV. How you do that is use the word import. And when you use the word import, you have to prefix whatever you've got in that package by the name of the import. Okay. If you don't like the name of the thing you're importing, you can rename it with an as, so that now I can refer to everything that's in that package by that as name, if that makes sense. Alias. So you can, when you import something like this, you're importing them in a separate namespace within your process called .o, basically, right? But let's say you wanted to import it directly into your namespace, so you didn't have to prefix it. You can do that by saying from time, which is the packet, the module, I want you to import sleep, and I want you to put it in my namespace. So now I don't have to prefix the sleep with anything, and I can just use it. I can do the same thing for another package, another module. Keep using the package module. I can import everything into my namespace. So now everything that's in the random module is in my namespace, and I don't have to prefix any of that stuff. Now the problem with that is you have naming collision problems. Got to be careful, right? So you do it. You want to use that with great care. So here I'm importing the platform. I wanted to show you this because this is how you do conditional execution for different operating systems. In sys, there's a method, or in this case, property, right, called platform, which lets you determine what kind of platform you're on. Are you Linux? Are you doing Apple? Are you doing Windows? And depending on that, you can execute a whole bunch of different code, including importing different packages, because packages are imported dynamically. And so, do I actually show that? Well, I do, but I do it in a different way. You could have put an import right here, and then it would import something, something, something. Final thing, you can import packages very dynamically. And in this case, I used this code to do create plugins. So my Python system has a directory that's a plugin directory, and I can just throw whatever I want in there. And it's basically doing model comparison. And so if I have a new model, I just throw it in there, and it can then compare that model, the new model that it dropped in, with any of the other models that I have. And so I can just add new models as I go, and the comparisons can be made. And what I do is it basically goes to my plugin directory using glob, right? We talked about Glob. It finds all the files with some name that says, oh, this is my entry point for my plugin. And he then takes that, creates the module path name, which is, remember, it's like name, dot name, dot name. So it's basically making it a dot notation. And then I just do an import live to import that module. And now that code is actually in there, accessible. And if the code is smart enough to ask for a global value that then registers itself as a plugin to the main system, I can call it whatever I want. And so now I have plugins. Questions?